Okay, today we're going to start Unit 6, which is ratio and similar triangles, actually. So today we're going to talk about ratio and proportion. The aim is ratio and proportion. Okay, so what's a ratio? A ratio is a comparison of two quantities by division. And so we can represent, it can be written in three ways, can be written three ways. We can write, A to B. We could write A over B, or we can write A colon B. So this is a comparison of two quantities by division. So good. Simplest form, I guess for now I need a new pen. Let's throw this away. Nice. A simplest form is a ratio fully reduced. It's a fully reduced ratio. So I might say to you, I might give you a rectangle, and this is the base, and this is the height, and I might say, it's 6 centimeters to 8 centimeters, and I might say, what is the ratio of the base, the base to the height. Right? So you might write, 6 to 8. You might write 6 over 8. You might write 6 colon 8, but you also can write, or you could say, you know what? It's not in simplest form, so I'm going to write it in simple form. The ratio is 3 to 4, 3 to 4, 3 to 4. And the idea is also try to keep the units the same. So let's see, try to keep, the units the same. So in the same rectangle, let's say that the height is 1 foot and the base is 7 centimeters. Instead of writing 1 to 7, you would write 12 to 7. Same idea. No, I'm sorry. Sorry. I said base to height, so if we're going to keep that, it's 7 to 12. Nice. Let's look at a word problem. I'm going to say it out loud, put it on pause and see if you got this right. The ratio of boys to girls is 5 to 2, and there are 35 students in the class. How many boys and girls are there? Let's see. The ratio of boys to girls is 5 to 2, and there are 35 students in the class. How many boys and girls? How many boys and girls are there? And once again, we're assuming there's only two genders. So you might say, you might write, okay, boys over girls is 5 to 2. But remember, this might already be in simplest form. So it might be a multiple. For example, it might be like, 10 and 4, 15 and 6, 50 and 20. But we don't know what it was before it got reduced to 5 over 2. So let's make the ratio of boys to girls 5x to 2x. Well, therefore, I know that I can set up an equation. Therefore, 5x plus 2x equals 35, 7x equals 35, x equals 5, and therefore there's 25 boys and 10 girls. Nice. The last thing I want to talk about is something called extended ratio. Extended ratio, and that's simply a ratio of 3 or more quantities. This is a ratio of 3 or more quantities. For example, I'm erasing. For example, the ratio of the angles of a triangle are 2 to 3 to 4. What are the angles of the triangle? So let's see, let me erase this. Let's see. The ratio of the angles of a triangle is 2 to 3 to 4. What are the measurements of the angles? Well, we're not going to write it as a fraction. We're not going to write this as a fraction because we can't write a fraction of 3 amounts. So we're going to just look at the ratio. We're going to take 2 to 3 to 4 and say, you know what? I don't know. I definitely know the angles of the triangle are not 2, 3, and 4. I definitely know the angles of a triangle are not 4, 6, and 8. But I can say that the angles are 2x to 3x to 4x. That I know. It's some multiple. Now, back in guess and check days, you do 1 and the 2 and the 3, and you keep going up until you knew that the sum was at 180, but you've already had an algebra class, so you can say, you know what, Mr. Arthur? 2x plus 3x plus 4x equals 180. 2 plus 3 plus 4 is 9. 9x equals 180. X equals 20. Therefore, 40, 60, and 80 degrees are the measurements of the angles. And you can imagine the problems. The length of a side of a quadrilateral, or x plus 2x plus 3x, 1 by 2 by 3 by 4. Or, the angle, better yet, the angles of a quadrilateral are in the ratio of 1 to 2 to 3 to 4. Something like that. Nice. Next, proportion. Proportion. What is a proportion? Well, a proportion is a statement. It's going to be something equals something, and it's in which 2 ratios are equal. In which 2 ratios are equal. Okay? And first of all, I might say 5 equals 9. So you might say, okay, Mr. Arthur, that's a statement, but it's not true. So the idea is, if the statement is true, we say the ratios are in proportion. So, if the statement is true, we say the ratios are in proportion. Okay, so the question is, how do we, these obviously comes back to algebra. We're going to need this stuff for some geometry stuff. But so for example, I say, question, is 2 over 10 equal to 3 over 15? Are these ratios in proportion? That's what's going on. Sorry, question mark. Is 2 over 10 equal to 3 over 15? Are they in proportion? And so you would say, yes, these ratios are in proportion. Sorry. Yes, these ratios are in proportion. Okay, why? Well, the first method is, method one is that both the ratios have the same simplest form. Both ratios have the same simplest form. Because you would say, okay, well, 2/10 is like 1/5, and 3/15 is 1/5. Because they both have the same simplest form, the ratios are in proportion. Method two is something you might have learned. The product of the means is equal to the product of the extremes. So because 2 times 15 is equal to 3 times 10, because that's true, the ratios are in proportion. The ratios are in proportion. On a side note, why is this true? Why is this true? Well, let's set it up. Let's say A over B equals C over D, right? That's given. I provided you with a statement. And let's do some algebraic manipulation. Let's multiply both sides by BD. BD equals BD. We can do that by the multiplication property of equality. We know that B and D are not zero, so we have to worry about that. And then we see it cancels out. B goes out with B, so we have A times D. And the D's go out, so we have B times C. Nice. Let's move on. Now, so you can use either method to determine if the two ratios are in proportion. For example, does 5/9 equal 10/8? Let's say 12. And the question is, are these ratios in proportion? Who did I get a message from? Are these in proportion? You would say no. Either you say 10/12 reduces to 5/6, which is not 5/9, or you just cross multiply and hope that the statement is true. Does 5 times 12 equal 5 times 9? Is 90 equal to 60? No. Therefore, the ratios are not in proportion. The ratios are not in proportion. Okay, let's practice some algebra. Obviously, this always comes back to algebra. I can't help it. There's nothing I can do about it. So, for example, first example, 6/x equals 5/4. Let's see. Example 1. 6/x equals 5/4. When you see two ratios set equal to each other with a variable, assume they're in proportion and either of these rules work. So you say, okay, Mr. Adler is saying these two ratios are in proportion, therefore 5 times x equals 6 times 4, 5x equals 24, x equals, you should know this by hand, how to do this by hand. Let's see, this is 4.8. And let's try another one, example 2. 15/m+1 is equal to 3 times m. Assume this is true, therefore the product of the means does equal the product of the extremes. You have a couple of ways of doing this. Method 1, you could say, okay, 15m is equal to 3 times m plus 1. 15m equals 3m plus 3. 12m equals 3. m equals 4. That's one method. But some of you might say, you know what? I'm looking at these denominators, and you might say, you know what? To go from 3 to 15, multiply by 5, right? So therefore, to go from m to 3, to multiplying 3 by 5 gets you your 15. Therefore, if I multiply my denominator by 5, that should get me my m plus 1. So you can write 5m equals m plus 1, 4m equals 1, m equals 1/4. There's 100 ways to do these. I don't want you to say, well, Mr. Rattler said this. Like, if you see this connection, go for it. That's totally fine. Let's do some fun stuff right now. Ready? I want you to figure this out. I'm gonna write some things on the board. I want you to take a moment. Once again, I'm pretending this is a class that I'm in front of you. Let's see. I'm telling you that if x over y is equal to 5 over 6, I want you to tell me what is a 6x equal to. I'd like you to think about what y over x is equal to. I'd like you to think about what x over 5 is equal to. And then last, as a bonus, I want you to think about what is x plus y over y equal to. So, figure out by yourself, or maybe when you've watched the video, say, oh, did you get that last part Ms. Riley was talking about? Put the video on pause. Okay, we're back. So, let's see. We know that x over y equals 5 over x. Well, I cross-multiply here. So I knew that 6 times x equals 5 times y. I'm going to use a different color for fun. Right? What color shall I use? How about I use orange? So I know this is 5y. Y over x. What do you think? Well, you know what? It does work. If you flip it upside down, you flip this upside down. X over 5. Well, let's think about this. We have x is to y, as 5 is to 6, but you know what? X in this last problem, we saw 3 is to 15, as m is to m plus 1. So you know what? X is to 5, y is to 6. That makes sense. What about this last part? Well, it seems a little confusing, but it really isn't. If I tell you the answer is 11 over 6, what do you think? Well, at this point, you say, you know what? He wrote this, Mr. Allen wrote this, I can break this up. It's like adding 1 to both sides. So it would be like, 5 over 6 plus 6 over 6. Nice. Do everything in unit, what is it? 6.1. Nice. Excellent.